Good day, everyone, and we're happy to be back in this new week. Now, we are done with modular arithmetics. We are moving toward mappings and functions. We need to understand, to get what mapping is all about, there are terms that we need to understand, and we need to know these terms like, let's say, the definition of mapping, what it actually means. Mapping is simply mapping can be described as a relationship that associates an element in A, let's say A, which is called domain, to another given element in B, which is called codomain. This is what mapping is all about. We said mapping can be described as a relationship that associates an element in A, this element in A, which is called domain, to another given element in B called what? Codomain. Now let's show what this is all about. Let's say we have this. This is A, and this is what? B. Now let's say we have what? 1 here, 3 here, 5 here. Then you have what? Let's say you have 4, you have 6, you have 12. Now, look at this. Look at this. You see, this element is what? It is associated to this element in B. The element in what? A here, which is 3, is associated to what? The one in what? In B, which is what? 6. This 5 is associated to what? The element what? Within B, which is what? 12. So this is the relationship mapping is talking about. And it shows that what? Each domain has what? An element in B that serves as the output. We can also see, look at another one. We could have something of this nature. Let's say we have something like this. We have something like this. It mustn't be that it must be straight. Let's say we have A, B, D. Here you have what? F, G, H. Now, A could be what? Now let's see this word, P, Q. Element P, which is a subset of elements in what? A, which is a subset of element in P. Let's say this is linked to this. This is linked to this. And what? This is linked to this. The main thing here is that what? Each of the elements in P, set P, has what? Is associated with an element in what? Set Q. Now we need to know, okay, what are these elements in P? What are they called? Like we said, this is our domain. You can see domain A, B, D is associated to what? The element in what? Set Q, which is what? Codomain F, G, H. Each of them has what? Element that is linked to. So it means it's like what? The input A has an output H. Input B has an output G. And input D has an output F. Now, look at this. We can say, okay, domain A has what? F. G as its image. Domain A has H as its image. We can say, let's say, F of what? Or P of A, the set A, the image is what? Is H. Then we can as well say that what? P of B has an image what? Image G. Then P of D has an image F. So what we are saying about all the output of what? Output of A is the image of A, which we call codomain. These are all codomain. And these are what? Domain. Now, this H is image of A. G is image, element G is image of B. Then F is image of D. When we combine all these images, when the images are listed as a set, excuse me, are listed as a set, that is, we have what? H, G, F, they become range. So the range of this domain, we can now say domain, let's say P of what? A, B, D, which is what? Domain, has range H, G, F. Now, what we are trying to prove here is that we are trying to show us meaning of what? Domain, that is our input. Codomain, the output, that is when you input one, the output, which is what? 4. So we know what domain means. We know what codomain means now. We've also stated what we mean by image. Image is an output of each domain in a set P. That means we say set P with what? An element A has an image H. Then set P with an element B has an image G. Then that of what? D, which is an element in set P, has an image F. Now, when we list the images, when we list them together as a set, they become what? The range. They become range. So we say range of set P are H, G, F. In a nutshell, this is what definition of mapping is all about. That every input must have an output. Every domain must have a codomain. And this codomain must be unique. Now, let's look at this. Let's say we have element this, f of x to give output y in this form. Let's say we have something of this nature. Now, let's say A, B, C. Now, let's say what? Okay, we can use another alphabet. Let's say we can use any number. Let's say 3, 4, 9, 6, 8, 11. Now watch. And we are asked, look at this. F here, there's something. You can see that what? There is an element here in our what? Domain, which has no image. It has no image. Now we can say F of what? S, Y is not a mapping. Why? Let's put it down here, the reasons. For a relation to hold, for a relation to exist in mapping or function, these 2 points must be established. 1. Every element in domain must have what? An image in codomain. Every element in domain. Now, every element in domain must have an image in codomain. 1. Every element in domain must have an image in codomain. Then 2, the image of every element must be unique. What do you mean by this point? It simply means that what? No image, we have what? No 2 images, we have 1 element in domain. That means, okay, let's use 2 points to buttress, 2 examples to buttress this particular point. Now look at it. This same relation we used before. Let's say something like this. F of function x produce an output y in this form. In this form. Let's say we have A or P, Q, R, then U, V, W. Now look at this. If you have something like this, we have this, the relation above is a mapping. Because, why? It is so. It is so because every element in relation S to Y has unique image. Now look, P, the image of P here is what? W. The image of Q is what? U. And the image of R is V. Look at this case 1. Case 2. Let's look at it. G let's say relation of G to what? P output Q. You have something of this nature. You have 1, 2, 3, 5, 6, 7. Now let's look. Look at this. Let's look at this. The relation 2 is not a mapping because image 1, element 1 does not have a unique image. Element 1 has an image 5 and it also has an image 6. It shows that what? It doesn't have what? A unique image. Therefore, relation 2 is not a mapping. Does not have unique image. So it is not a mapping. Why? Because element 1 is having 2 images. And the Lord says that what? For every relation to be a mapping, each element in the domain must have what? An image. And this second consideration or theory is that each image must have what? Must be a unique value to an element in the domain. Now, let's see third point. The third point, let's look at this relation F to S giving an output Y. Let's say we have something like this. And it goes this way. A, B, C. You have what? F, P, Q, R. And the relation goes this way. The relation goes this way. You have this. You have also this. Now, okay, looking at what we've done, you follow us on our next video to fully give us several examples where we can identify relations that are mapping and the ones that are not mapping. Thank you. We'll see you in the next video.